So let's look at exponential function in the light of calculus. How do we deal with that? So in this question, we have the speed function. So that's our value of y. It's a speed of a skydiver who jumps from an airplane. And then t, which is x, is time in seconds. Now, when we have a big question that has to do with speed and time, we always have to kind of consider or have in the back of our mind that speed and time is connected with distance and time formula and acceleration and time formula. So how do we cross over? If I'm going from distance and time to speed, I do what? I derive. When I go from speed to acceleration, I derive. If I have acceleration, I want speed, I integrate. And then speed back to distance, we integrate. So that idea is very often used in your exam. So like here, when you have a speed formula, a speed function and time, we can derive into acceleration, or that same one can be used for integration for distance and time. So that's a little bit of knowledge to have here. So in this part, we have to find the acceleration. That means what? Derivative, the rate of change of speed, because acceleration is derivative of speed and time, of the skydiver 1 second after they jump from the airplane. Give your answer in meters per second, square correct 1 decimal place. Now, when we are deriving, so when you are looking at that, you're saying, I'm not really sure how do I treat that. So how about if we multiply that by bracket by 54? Therefore, we can identify those elements a little bit easier for our differentiation, because we understand we differentiate each element on its own. So we have one element and then we have the second element. So that does make it slightly easier. So that will be 0 because a number in process of differentiation go to 0 without the variable. And then we are working here. Now, because in your exam, very often they like this type of exponential function with e as a base, and the power that has two elements, have the variable and additional number, I'm always saying it's good to, I know we have a formulas in the table. However, I tell you it's good to know that a derivative of this function will be that same function exactly multiply by the derivative of power. I'm excuse me, I'm advising you to know that, because that's a very important knowledge, and especially that your exam really like this function to be there. Okay, so that means what happened with 54, that crosses over, isn't it? So minus 54 will cross over, then multiply by the function that it is given to us, and then multiply by the derivative of power. Derivative of power, that is linear situation, so it will be minus 0.2, isn't it? Now, we don't have to just find the rate, we don't have to find the derivative, but actually a value of it when x is what? 1 second after they jump from the airplane. So in this case, we are looking for the value of this derivative when t is plus 1, and all we do replace, we don't have to work these numbers, we just replace t with 1. We put everything in the calculator, we press equal, and to 1 decimal place we should get 8.8. So again, can't stress it enough, that's one piece of information that I am advising you to have and remember.